All right, so we got 5-1. This assignment counts as 2, and it's a big one, but it's a very important one. So first up, that I've got selected here to do with you is 3x to the 5 6. So this is using this x to the power over root notation. And it's not hard. Most kids do pretty good with this on day 1. By day 3, they forget all about it. But what we're doing is we're taking the 6th root, because there's a 6, we're taking the 6th root of all of 3x, and then we would turn around and raise it to the power of 5. Or, and be very careful about this, the 6th root of a 3x still in parentheses to the 5th power. Those parentheses are a big deal. They really are. All right. I've also got number 6 highlighted here to do with y'all. Still the same thing, it's power over root. And the understood number on the square root is a 2. It's the 2th root. I wish I could write it 2 small enough for that. But there's an understood 2 right there. So when we change over to our P over R notation, we're going to have a power of 3. There's your power. And there's your root. So it's not too bad. You can take all of 5x minus 2. You're going to cube it and then take the square root. Easy peasy lemon squeezy. Hopefully. All right, moving on down. Evaluate without a calculator. It looks like I've got 7 and 10 chosen. These are traditional non-calculator problems. You just have to understand power over root. So let's look at it here. Your power is 3. Your root is 2. So what we're doing is we're taking the 2nd root, which is the square root of 16, and when we're done, we'll cube it. Like that's how you do it. So the square root of 16, last I checked, was 4. And if I cube it, I would have 64. Because 4 times 4 times 4 is 64. Do not be the kid who thinks that's 12. I'm so tired of that kid. Don't be that kid. All right, I got number 10 highlighted. First thing on 10 is a rule. It deals with negative exponents. So 1 over x to the negative n is x to the positive n. So I'm going to take what I have and I'm going to rewrite it as 81 to the positive 3/4. Remember, this is your power, and this is your root. Now, I show you 2 different ways of rewriting things, but you can say that you are taking the cubic root of 81 to the 4th, which I know you can't do. I mean, 81 to the 4th is a huge number. Or you can take the cubic root of 81 and then raise it to the 4th power, which makes a lot more sense. Oh, did some stuff backwards there. My bad. You're taking the 4th root cubed or the 4th root and then cube. I didn't catch it till I realized there wasn't a 4th or 3rd root of 81. Now, turns out 3 times 3 times 3 times 3 is 81. So this becomes 3 cubed, which is 27. All right, so there's 2 more for you. Let's see, getting on to 14. 14 is a calculator problem. I'm going to modify these instructions. They need to say, you know, show the conversion, because you are not typing in that thing in a calculator. You're not doing it. You're not taking a 4th root in a calculator and then cubing it. Your goal here is to learn your exponential notation. So in a calculator, what you'd say is you have 87 to the power over root to the 3/4 power. And we're going to approximate that 10,000th position. That's the 4th decimal. So let me bring up my calculator here. Make it a little bigger so you can see it. 87 rooftop. Again, play along. Learn how to use your TI-84. Go to ti84calc.com. And I got about 28.4865. All right, easy. All right, what's next on our little list of things to do here? Get rid of you, go away, Don't want to see you. There we go. Goodbye. Looks like I've got 17 bolded. So 17 does have two answers. Now what we're going to do is we're going to do the easy stuff first. We're going to shift that negative 44 to the right-hand side. It's going to become addition. We're going to have x to the 2/3 is going to be 225, I believe. And we've got to fix this 2/3 power. The idea is that you multiply that exponent by something that would turn into a 1. So what we're going to do is we're going to take that 2/3 and multiply it by its reciprocal, 3/2. And if we do it to the left-hand side of the equation, we had best do it to the right-hand side of the equation. So 225 is also raised to the 3/2. Now what that happens is this becomes the first power, which is understood to be there now. We're not going to write x to the first anymore. What we're doing on the right-hand side is we're taking the square root of 225, and then we're going to cube it. Now, the square root of 225 is plus or minus 15. I promise you. And if you're the kid who just goes to your calculator, whoops. If you're the kid who just goes to their calculator, oh, it's still there. I thought I got rid of that thing. Come on back, TI-84, I need you. Apparently I'm not getting it. If you just go to your calculator, you're not going to get this thing right. Because if you just type this into a calculator, it's just going to say it's a really big number here. Let me pause real quick. I need my calculator back. Still no calculator. Yep, I broke it. Well, bummer. You won't see what I'm doing over here probably. No. Well, anyways, if I go to my calculator and I type in 225 to the 3/2 power, problem with the board here, I get 3,375. But the reason we kind of want to think about this old notation here is because when we take a square root and we're solving for x, we include the plus or minus symbol. It's plus or minus a 15 that gets cubed. And it turns out that 15 cubed is 3,375. So the two answers are plus or minus 3,375. Sorry you couldn't see my calculator on that. It is what it is. All right, moving on to the next page. And please tell me that that is not there. Half done. Looks like I've got 19 bolded and 20 bolded. So I've got x minus 5 to the 4/3 is 256. I'm telling you this has two answers because what you're going to end up doing is you're going to raise each side to the 3/4. The idea here is to make that 4/3 disappear, and we do that by multiplying that exponent by her reciprocal, and her reciprocal is 3/4. And if I do it to the left, I had best do it to the right. And most kids aren't going to realize, but you're taking an even root, and you probably won't realize until you actually write it out that it's an even root. So I do like to switch back and forth between radical notation and exponential notation. On the left-hand side, those guys cancel, and that gives me x minus 5. On the right-hand side, what I am doing is I'm going to take the 4th root of 256, and then I am going to cube it. You know, so what is the 4th root of 256? It turns out it's 4. 4 times 4 times 4 is 256. Now, because it's an even root, plus or minus, x minus 5 is plus or minus 4, then I turn around and cube. All right, so if I cube that, x minus 5 is plus or minus 64. So that means x is going to be, think about your shifts, 5 plus 64, which is 69. And a lot of kids would say the other answer is negative 69 because they don't actually do the arithmetic. They think, but their thinking ain't right. The other answer is 5 minus 64, which is negative 59. There's your two answers to that problem. I can't tell if it's, I think it's 21 that I've got bolded. So 21's the next one to do it. I wish I had a good working blue pen. Maybe this one works. What we're going to do easy things first. We're going to isolate our radical. So we're going to take this 3 and we're going to shift it on over. That's going to give me the cubic root of x minus 2 squared, which I am going to rewrite using exponential notation. X minus 2 to the 2/3 equals 4. Now, the opposite of the 2/3 power is its reciprocal, which is the 3/2 power. So I'm going to raise both sides to 3/2. That's going to free up x minus 2. I am going to think about this as a radical again. It is the square root of 4 that I turn around and cube. That's an even, right? We got to include plus or minus. X minus 2 is plus or minus a 2, because the square root of 4 is 2, that I cube. So x minus 2 is, if I cube a 2, I think I get an 8, plus or minus 8, which means that x is 2 plus 8 or 2 minus 8. So your two answers here would be 10 or negative 4. Nope, sorry, negative 6. I don't know why I wrote an 8 there. Or I wrote something else. I think I wrote a 6. And 2 minus 8 is negative 6. I was probably thinking ahead to answers. All right. I'm good with that. It looks to me like I bolded 22. Not because you don't need to try and do it on your own. Probably because I didn't want to spend class time the next day doing it. That's probably why I bolded it. It looks bolded. So we're going to do it. Find all zeros of f of x equals x cubed plus 4x squared plus 25x plus 100. And I suggest factoring by grouping. But what would I know? I'm just a math teacher. So I can pull an x squared from both of those pieces. And if I do that, I'm left with x plus 4. And it turns out I can look at the second grouping here, and I can pull a 25 from both pieces. And by golly gee wow, I've got an x plus 4 as well. Now, since I'm finding zeros, I'm going to say the whole thing equals 0 so I can use zero product property. I'm going to keep factoring, because if I was a Greek god, I would be the god of factoring. That's who I would be. Common factor is x plus 4. The stuff left over is x squared plus 25. Now we're going to use ZPP, zero product property. I was helping a kid in college algebra today, and they forgot about the zero product property. They're about to take a final in college algebra, and they forgot about the zero product property. They don't have an A, by the way, but still, how do you forget about ZPP? And how'd you get to college algebra? Like you had to done gun, whatever. X plus 4 is 0, so x is negative 4. Need to quit ranting. It's live on YouTube. X squared plus 25 is 0, so x squared is now a negative 25, and the opposite of squaring is square rooting, so x is plus or minus 5i. Now, of course, you can't see that because stuff is in the way. Fundamental theorem of algebra said you were going to have 3 answers. Negative 4 is one of them. Plus 5i is one of them. Negative 5i is one of them. Ta-da! All right, what have I got bolded here? Boy, it's hard to see. It looks like 23 and 26 maybe. So why not? 23 and 26. I know I chose 2 of them when I did it. So if it's the wrong 2, so be it. All right, now for today, it makes a lot of sense to use this x to the p over r notation. So what I have here is I have a 27 to the 1/3, and I could actually just leave that as cubic root of 27. Everybody should know what the cubic root of 27 is. That's 3. Then I have an x to the 12 over the root, which is 3. And I have a y to the 6th over root, which is 3. And then simplify. I'll have 3x to the 4th because 12 divided by 3 is 4. Y squared because 6 divided by 3 is 2. Easy peasy. And yeah, 26 is definitely the other one I have. And then I've got the last one, 27, for you. I did a good chunk of this sheet, kids. You're very welcome for that. Nobody ever says thank you. You should say thank you. You should. Because a lot of work's being done for you. So multiplication is basically gluing things together. Now, so your first line might be where you actually just stick everything together. Or you might skip ahead, but I'm not supposed to skip ahead because I've noticed if I skip ahead, people don't understand things. So I'm just going to glue this thing together. And I'm going to take it piece by piece. I'm not going to try to do too much at once. I'm going to focus on these things right here. Those are like terms. When we multiply like terms, what we do is we add the exponential space. So 3 plus a negative 2 is going to be 1. So I'm going to have a single x to the understood 1. I'll move that 9 out front because it looks better and leave y squared there. I have 3x y to the 4th. Now, this x also has an understood exponent of 1, so gone. 3 over 9 is 1 over 3. That 1's probably not going to be needed anymore because 1's in math are understood. And what I've got left is y to the 4th over y to the 2nd. Now, what you'll see often on a standardized test is they'll have an answer choice that has 3 over 1. Because a lot of kids make that mistake. Probably around 20% of the student body makes that mistake. Don't be that kid. It was 1 over 3, not 3 over 1. I got y to the 4th over y squared. And if I think about that separately, the rule for like terms and division is we subtract. So what I'm going to do is I'm going to think about, okay, this is really y to the 4th minus 2, which is y squared. So the final answer here is that I have a y squared in the numerator, and she's sitting pretty over a 3. Not bad. It's not. You just have to memorize rules of exponents and what to do. And a lot of times you memorize that through practice. You have to practice your work, kids. You have to. All right, last one. And again, you're welcome. You should really say thank you, Milbrath, but you don't. You're privileged, aren't you? You expect it. I think it's my job to give you a grade. Now, 27, I really should push this more. It's not in Algebra 2 standards, and it should be. It's called the U method of substitution. And it really, really should be pushed because, I mean, we use it in pre-calc, we use it in calc, but we're going to use what's called the U method. This is, I believe it or not, a quadratic. I swear it is. I happen to know that if you take x to the 1/5 and square it, because we multiply exponents, you get x to the 2/5. All right? So what I'm going to do, and anytime the U method comes up, at least all the way up until calculus, U is usually the thing in the middle that's funny. So U is x to the 1/5. I'm going to rewrite this thing so it looks like a quadratic. Now remember, I already explained that if you squared this, you would get this piece. So this piece becomes U squared. The middle becomes 9U, and then you have your minus 10. The reason that was done is because that's easier to factor. It is. To make a U squared, it takes a U and a U. Factors of 10 can be 2 and 5 or 1 and 10, but you got a negative 9. So you need minus 10 and plus 1. Still get to use the zero product property. By ZPP, U is 10 or U is negative 1. Now, U was something else. U was x to the 1/5. So x to the 1/5 is a 10, or x to the 1/5 is a negative 1. Now, both of these have the same exact process to figure out. The opposite of the 1/5 power is the 5th power. So what we do is we multiply the exponent on both sides by a 5, because cancellation. 10 to the 5th is a pretty good sized number. You know, 10 squared is 100. 10 cubed is 1,000. 10 to the 4th is 10,000. 10 to the 5th is 100,000. I don't know if you remember the shortcut, but it's a 1 followed by 5 zeros. All right. Over here, we're going to do the same thing. We're going to raise both sides to the 5th power. And if you take a negative 1 and you multiply itself by itself 5 times, I hope you understand you get negative 1. So there's your two solutions to that problem. It does say find all complex solutions, but it doesn't have any complex solutions. Those are the answers to that problem. And again, you're welcome. I hope you enjoyed the video. See y'all another day.